Alright, welcome back everyone. My name is Rajneesh Gupta and this video is about very simple smart contract. Of course, you're not expected to know about any programming languages like Python and Node.js, JavaScript and all those stuff. You can understand it very easily. That's what I can promise. Okay, and if you still have any question, you can ask me in the comment. Alright, so enough talking, let's get started. Before we even code this very simple smart contract, we need to understand two very important stuff. The first thing is accounts. Well, just like we do transfer money, but in case of Ethereum, for doing any kind of a transaction, we need to have an account, right? Personal accounts. If we go for any wallet, or even if we download the Go Ethereum or Ethereum wallet as well, we need to have an account, right? We create that. Similar to that, there is an account needed for a smart contract as well, and this is automatically created. Okay, so externally owned account or EOA is something which is being managed by the end user and owned by the end user, and smart contract accounts is something owned by the smart contract software itself. All right, so that's something which you have to keep in your mind. The next thing is we'll be talking about functions. Now function has got two aspects that you should know. First is the visibility. The visibility can be public, external, private, internal. Of course, we'll be going and we'll be talking each one of them, but I don't want to keep the entire video sessions boring, so I'll be making use of them whenever it is needed in the practical example while we code. Okay, so as a part of this smart contract, we'll be making use of a public. Remember, this public and external are similar in nature. It's just that when you make a function visibility as a public, it means that it can be accessed internally and from the outside of the world. When I say outside of the world, it means from the front end application, the legacy application as well, right? When you make the visibility as external, that means your function can only be accessed from outside of the world, but it can be accessed within your smart contract. You got it? Or from any other smart contract for some reason. Okay, so that's the purpose, and of course that saves gas as well, right? Now there's a types. Remember this, when we talk about the types can be view and pure. When you make your function as a view function, that means it can just view the variables. Okay, your function can view the variable, that's it. It of course cannot write or modify something to it, but it can view the variable information. But when you make it pure, it can't even view it. Okay, so that's the difference. All right, so enough talking about the fundamentals. This is all housekeeping stuff. Let's get started with our IDE. All right, so we are on our IDE. IDE is the platform where we develop our smart contract. This is being delivered by Ethereum itself. We call it as Remix. Remix.ethereum.org is the place where you can find it. All right. So before we code, I just want to show you what all you see when you start. First thing that you see here, it's the file place. Okay, and this is what you can see. This is the file place, and the next stuff is about the compiler. Okay, and this is where you can see the Solidity compiler. Just like any other programming language, you code and then the compiler or interpreter in some cases go through the code and then convert the high-level languages into low-level languages so that the machine can understand, right? Then the third is about deploy run transaction. You see, Ethereum is very different from the normal legacy application. or coding languages itself, because normal languages it's all centralized, but Ethereum, once the smart contract is developed, it has to be deployed on blockchain, and that's why we need to take care of we need to deploy the smart contract on blockchain and test it. Okay, there is no other way. That's why we have the third option. We'll definitely be talking about it. Let's come back. The first line starts with the license. You make sure you make use of either one of the license. Either you make use of MIT or GP. You can make use of GPL as well. That's up to you. But make sure you have. Otherwise, you will keep getting the warning messages. The next thing that you have to do is, the very first thing I would say is to define the Solidity version. Okay, so you define the Solidity by making use of Pragma line. That's going to be 0.8.11. That's the latest compiler version. You can even verify that. You can go to the second tab and you can see, okay, 8.11, that's the recent one, and you can see perfect. All right, now this is the way you define the compiler version. And now next thing is you have to define the contract. So for that you need to type contract and the name of the contract. See, the name of the contract should start with the capital letter, just like those who know about the object-oriented programming languages. The name of the class starts with the capital. So let me make it double my money contract. Okay, and then curly braces, and I have just one activity to do, right? So just like any other program, what you see, variables, function, variables, function, variable, function. The purpose of variable is to store some value, right? That's the reason we create a variable, right? And the purpose of function is to perform some activity. So you take some value, you perform some activity. At this moment of a time, we have just one activity, and that's double my money. So I'll create a function, double my, we'll make use of camel case, double my money. And because in order to double your money, you need to take a value from the user, right? You need to take some value, maybe let's say 4, 5, 10, and then you double it, right? So that's where you need a user intervention so that he can enter some value. And that's why you need parameters, right? So I'll make use of parameters here, and I'll make sure, because it's gonna be integer, unsigned integer, because I want it to be positive always. So of course you can make any amount, so you can keep it as amount. It's up to you, you use the underscore or not. I just have a practice of making use of underscore whenever we have a parameters where we want user to enter some value. Okay, then we define the visibility of the function. You remember we talked about the type and the visibility. Let's keep the visibility as public, so that this can also be used by the front-end application. You see, currently we are not really making a full stack DApp, okay, decentralized application. We are just making smart contract. Still, we need to make sure we are following the best practice. So keep it as public so that the application can access it as well. We'll keep it pure because we just want the value to be doubled, and because there is no variable created, so we don't need to worry about making it view. You remember, we make use of view only when we want to view the information of your variable. If there is no state variable or there's no variable, there's no need to make it a view. Okay, so the visibility is pure. The visibility is public and the type is pure, right? Now we want it to return something. You see, we want it to return, and what we want to return is the integer. You see, I know this is going a bit lengthy, but remember this: visibility and the type is something you have to define. But just like any function returns some value, Solidity is very static in nature. just those who might be coming from Python, they understand, okay, even by defining, you don't really have to define its integer or string or something, right? The Python understand it by itself. That's very much in dynamic in nature, but Solidity is very static. You have to specify everything yourself, because it's everything that you type has got money involved with it. So under this, then you define what you are actually trying to return. So I'm returning double the amount, right? So that's the amount. This is what, right? This is what user entered, and then I'm multiplying it with 2. That's it. You see that? It's that simple. Now you can either it's automatically saved, but you can even compile it as well. So first, once your code is ready, you need to compile it. So you go to your second tab here, and then you can make use of the compiler, and just click on the compile. Okay, and you see there is no error. If there was any error, you might have got a red message or indication, right? An error, of course. Now you go to the third tab. That's where we are going to deploy our smart contract on the blockchain network. Now the question is, where exactly is the blockchain network? You see the Ethereum IDE, the Remix IDE itself running a blockchain network behind the scene. So you might ask, okay, so if we are running the smart contract on the Ethereum, then we might have to pay some money as well, right? Well, no, it is really a sample or test network where money is not the case. Not really exactly the test network as well, but it's just that it's the Remix own environment for the lab purpose. So that's the reason you get, 2 JavaScript virtual machine, which you can run it yourself. So you can select any, but make sure you select JavaScript as a part of this session. This is where your smart contract will be installed. If you recall my earlier video where I talked about what is EVM and how that works, you get the better understanding. And next is accounts. So by default, to test your smart contract, Ethereum Remix provides 10 sample contracts, 10 sample accounts holders with some fake ether. Okay, what are those? You see this 10, are this 10? I think that more than 10. Okay, maybe they have added some more. Okay, and each one of the accounts are having 100 ether. You see, I told you, right, the transaction can happen between one account to another account, or one account to another smart contract account. Now in our case, we are going to do the transaction between the first account. Maybe let's say we select the first account, which is who is having 100 ether at this moment, with the smart contract account. What is the account number of smart contract? That's the question, right? We'll get to see about it, don't worry. So the moment we deploy and it get deployed successfully, we get to see the account number of our smart contract. Okay, so we have selected the first contract. This is the user who is going to deploy this smart contract on the Ethereum network. We click on the deploy. Wonderful. Now the moment we deploy, there's something happen at 2 places. Over here, you see something over here, right? The double money, and when you click on it, you get to see some parameters. Okay, and now what really happens is you also see something over here as well. And when you click on it, this is the debug and all the transaction logs that has been generated. Okay, this is where you see the transaction hash. For everything that is being generated, there will be a transaction hash, and who actually deploy, who actually sent this message, the account number of account, externally owned account in our case is this, which is starts from 5B. You can see this starts from 5B, right? And you can verify he's the one holding those amount, right? So this is the from, and this is the to. You could see to, right? So the to is my smart contract. To is my smart contract. You could see the double my money account contract basically. And there is some gas which is being charged for everything that you do, for every transaction, for everything that you perform into the Ethereum. You need to pay some gas, yeah, right? So for if you have a car, you need to travel anywhere, you have to pay for your gas. It will consume, your car will consume some gas, and you have to pay some money for those gas, right? So that consume this much of a gas, and this is the value of those gas, right? Now this is very good. We are good till now. Now let's look at some of the valuable, right? The moment we deploy the contracts, we got a indication defined that we can execute something with it, right? So it is asking us to enter some value, and it is unsigned integer and amount. What is that? You see it is underscore amount, the amount which we have mentioned here, right? So this buttons actually created, this is nothing but our function name. So every function that you create, automatically you get an option to execute it, right? So the way, if you have made use of Python or JavaScript or something, you get some value and you enter some value and function perform, right? In case of IDE, in Remix made it very, very beautiful. You get the function button yourself, so that you can perform your activity just with one button, one click. Okay, so it would ask me for some number. Let's say I enter 10, and what is expected is 10 to become 20, right? So I'll enter 10, and then I click on the double my function. This function should double my money, and you see it doubled my money. Now the current value is 20. How can we verify? Just click on this value. You see now this was another log has been created, and this log again, this was initiated by this account, the very first account 5B, and 2 for whom? For the smart contract. Now you can see the account number of the smart contract. You see this double my money contract, and this is the smart contract account. Lovely, isn't it, right? This is the gas amount charged, this is the hash. You also get to see the transaction hash. In the real world, whenever you perform the real money transaction, because these are all fake ether, but when in the real world, whenever you perform some transaction, you get your transaction hash. With the help of those transaction hash, you can verify the status of your transaction. You get the visibility about who transfer to whom and all those stuff, right? So you also get the idea about decoded input, decoded output, and this in the decoded output you get the value as 20. All right, lovely. I think you got the idea about how this very, very simple smart contract works. My purpose was not just to make this very simple smart contract, but to also give you an idea about how it works behind the scene. All right, if you have any question about this entire video or any point in the Ethereum or smart contract, you can ask me in the comment. I would love to answer that. All right, welcome back everyone. My name is Rajneesh Gupta. I hope you're enjoying this playlist so far. We have just completed building our very first and very simple smart contract, double my money, and we have done that just by making use of a single function. Okay, and as you can see, we made use of in order to make that possible, we understood about what is account, what are accounts basically, not just one. Externally on account, which are for the users, and smart contract accounts, which is owned by contracts, the contract account itself. We discuss about the functions, and in this case, what's really in this video, what we are really going to talk about is the state variable. Trust me, this is going to be fun. You will understand how you how the smart contract we can play across, we can define values, we can maintain the state of the smart contract as well. And I hope some of you can correlate it if if you have some sort of experience with Python or JavaScript and all those stuff, right? So we talked about visibility, of course, public, external, private, internal, and all those stuff. In this case, we'll be making use of one of these type. I'll keep it surprise for you, and we'll get to it once we start coding it. All right. We'll talk about the variables, because this is all about state variables. So we'll be covering the state variable for this session. Okay. Local variables are the one whose scope's limited inside the function. Okay, there's no, even if you have the same variable outside a function, you don't overlap. Okay, but state variables are the variables which maintain their state throughout the contract. Even if they pass one function, another function, they maintain their state, they maintain their value. If one function, the variable value got incremented by 1, the next function, you see the existing value will be 1. If you add 2 into it, the next third function, the value of that variable will become 3, right? So that means state variable maintain the state of the entire entire value. In fact, global variable is the variable which basically talk with the blockchain network itself. It talk on the transaction level. So global variable is the variable which connects, which can connect to your smart contract with your underlying blockchain network. We'll talk about it. Don't worry. Okay. So without taking much time, let's get started with our remix. All right. So we are on our remix at this moment. Now this is the code we used when it was very basic, right? There wasn't any variable used, right? And for some of you who might have understood variable in a different way, just to give you a recap, variable is needed whenever you want to store a value into something and you want to make use of it maybe later. Okay, so that's the reason we make use of a variable. At this moment, let's create one variable. Okay, and this variable, because I want this variable to store a number, money itself, so I'll keep it unsigned. Okay, integer but unsigned, so that it's always be positive, so I don't really have to care about it. And I'll keep it public so that it can be called from external applications as well, or across the contract itself. Okay, so I'll keep it balanced. Okay, and so just think about it, whose balance would be, of course, the smart contract balance. All right, so we don't really need the return, because we want the same thing to be done by making use of state variable. So we want the state variable to store the value in spite of just function giving us the response of the value. I know it might be confusing at this moment, but I'll clear that out. Don't worry about it. Okay, let me cancel it. Okay, let me close that, some of the unwanted stuff. So we created a function double my money. We of course need some value from the user. We'll keep it public. And if you remember, we need visibility and we need type, right? We can either have view or pure. We made use of a pure because there wasn't we were not really looking at the value of the state variable. Okay, but in this case, I'll show you something. In this case, we are actually going to update the value of our state variable. This is our state variable, and what we are actually going to do is our state variable will be updated with some number, and that number is amount. That number is amount into 2, right? And if we keep it pure, see what's going to happen. So this is our contract. We have to go to compiler and we have to compile it, right? Now what's wrong here is two things. Okay, first of all, we don't have the curly brackets to complete this contract. Okay, but even if you do that, the challenge here is you get an error saying that it's a type error saying the function declared as pure, but the expression is potentially be required non-payable, which is not good practice. The reason is if you keep it pure, that means your function cannot view the state variable. That means it cannot view the balance. Okay, that means it cannot view the what actually the current value of the balance. That's why you need to keep it view. Okay, and even if you don't do that, it doesn't matter. Okay, it's by default be view. And but now when you compile it, it's gonna work. You see this? It's that beautiful. Okay, but make sure you choose your visibility and types wisely, because everything costs gas. Okay, so your pure doesn't cost half of the gas, and your view cost probably double the gas. Okay, so this is done. So what do you think what's going to happen when you go to the transaction deploy and run? You choose, of course, your environment. We'll definitely talk about injected Web3 and Web3 providers when we are actually going to deploy the real world application. At this moment, we'll select the first account, the account which would be deploying the smart contract. Let's click on deploy. A smart contract is deployed. When you click on it, what do you think what you get? Basically, you are going to get, you're supposed to get two buttons, right? This would be function, and there is one more, which is your state variable, because it maintains the state and it's in the public. That means your Ethereum remix can see that. That's why you must see these two buttons, right? So you should be able to double the amount, but the benefit is, you can always check the status of your account. If you see earlier, you were just about to click on the button and there wasn't any state, there wasn't any way where I can get the current balance, right? So let's say I just double my amount by 10, right? Or maybe let's say this time 20. Okay, I click on it, I should see the logs, and in the logs the transaction should be initiated from the from account, which is correct. There's no difference. From is correct, to is this is the smart contract account number of this, and of course the value should be incremented to this, right? Now the point is, the thing that we really need to understand here is the balance should be updated. This is the number we are talking about. This has to be updated, right? So if we click on the balance button, now it should be 40. Why this happened? Because you entered a value to, you entered a value 20. Earlier we were able to get the response, right? We were able to see what's really happened, and we have to look at the transaction log every time. We checked the log and we got the idea, okay, the money actually got double. But we now have a button wherein in the program itself you can anytime look at the current balance, and if you go into it, you can get to see the unsigned value, which the 20 became 40 at this moment, right? So this is how you create a state variable. And remember this, the value of the state variable will be persistence even if it crosses multiple functions. All right, so I hope you got the idea. If you have any question related to view, what is pure, and the visibility of the functions, or state variables, we'll definitely be talking about it. You can ask me in the comment. I would love to answer that. All right, welcome back everyone. My name is Rajneesh Gupta. In this video, we are going to learn how we can send money to smart contract. Okay. All right, so let's begin with it. So in this video, in this activity, we are going to do this, right? This is much clearer. But for this to achieve, we have to create a special function for this, right? We already know about the visibility. We make use of public visibility. We have tried view and pure, both of it. In case we want to make use of a state variable, we make use of view so that the function can view the value of state variable. We talked about state variable in this case, but the one thing that we are going to make use of to make this possible is called payable function. We have to make our function payable, and I'll show you how. All right, so we are on our IDE, the Remix IDE at this moment, and what we want to achieve is we want to have the contract would be exactly same. Only thing that we need is to send the money to smart contract in this case, right? So let's keep it as it is. Let's create one additional function, and the function name should be send me money. Okay, and who is that me? Of course, the contract. So I just keeping the name so that we can get the idea. The only thing that you don't really have to provide something in the parameter at this moment, but just make sure you always make use of a keyword called payable whenever you want your function to receive some sort of money. I mean, any ether, right? So you keep it payable, and that's it. Okay, that's all it is. Now, how can we verify that? Well, the first thing that we need to do is, of course, we'll first compile the code, and lovely, you can see the green check, right? So the compilation works, there's no error. Now let's go and send some money to our contract. So how do we do that? First step is to deploy your contract. Okay, so we'll deploy, and what do you see, what do you think, what all you gonna get? Basically earlier we had one function and one state variable, so we had two buttons. This time we should have three, right? One for the state variable, that's balance, to always check the balance of our state variable in that, and double my money, that's our function. And this time we have send me money contract. This is the one which allow anybody to send money to the smart contract. Okay, and how do we do that? You see, we have got externally owned accounts which are 10 sample accounts, so we can send some money from either of these accounts. So we have been selecting the first account every time, so this time let's select the second one, AB. Okay, remember this AB. Okay, from this we need to send some money to smart contract, so we define a value, right? So let's say we send 5 ether. Of course, in the real world this is huge, but this is fake, don't get so excited. Okay, so this is we'll not select view away. Away is basically a very small denomination, very small unit of it, but we'll select ether. And the moment I selected the value and define the unit as ether, I need to make use of this function, which is send money to contract button. The moment I do that, this sample account AB should be sending the money to this account. Let's see. Wonderful. Can you see something happening? And a log has been generated. If it wasn't successful, the green wasn't there, it should be an error. Okay, but it states that it was successful. So this time the source was this account AB. Can you see this? You could see AB is the one, and yep, this is the one, right? And you can see the transaction given. The transaction was for the smart contract. this much is the gas which was used and the gas price, transaction cost as well. And what is really important is the value. Can you see this? This VAL, this is basically I would say an object on the global level. And in the future, in the future video, we are going to make use of it to make sure that we retain the current state, current balance of the smart contract. So we'll talk about this, but remember this: the val is something which indicates what's the current value in the smart contract at this moment. So we have sent 5 which is 5 ether in a way. Okay, so that's the case, right? So we have current successfully sent this much of amount. Don't think about balance at this moment. Don't think about doubling your amount at this moment. Okay, and because at this moment we don't have anything inside, so your function, your function send me money contract is just ready to accept some money, but it's not performing any activity. Okay, and what exactly it can do, we'll talk about it. What all we can do further into it, we'll talk about it in the next video. Okay, till then, if you have any question, you can ask me in the comment. All right, welcome back everyone. My name is Rajneesh Gupta. In this video, we are going to make use of a global variables. All right, so the purpose would be same. We'll have our smart contracts receiving money from the externally owned account, and of course we'll be having a function which can double your money, right? So let's get the basic understanding about what all we are going to do. As I said, the function would be same, everything would be same. We'll be making use of public, we'll be making use of view because there is no return and we want our function to update the existing value as well. Now what we want to make use of is the global variable. You see, global variable is the one where your smart contract can actually talk to the blockchain network with. Okay, so it's a global variable. It's a global variable which allow the communication, which actually fetches the information about your blockchain. And what are those information? It's basically messages. So start with MSG message. Okay, and it could be MSG.value. It could be MSG.sender as well. Okay, so let's say if I send some information, so by default on the blockchain, the metadata would be mentioned as MSG.sender is the source. Okay, and let's say the transaction amount was somewhere around 2 ether, so by default the metadata in the blockchain would identify that value as MSG.value. So those are metadata. Okay, and in smart contract we can actually fetch those information. Those information can be fetched by making use of this global variable. Okay, so enough talking, let's go to our remix and explore it. All right, so we are on our smart contract as we left. Let me cancel it. Okay, yeah, as we have completed our function of doubling the money and the function to receive money, and of course the state variable balance as well. We can try changing the name of it, received balance maybe, and once you change it, you have to change it here as well, received balance. So we are changing the name of it. And what we want to do is whenever there's new amount coming into the smart contract, it should be updated. So every time maybe a new account comes in, okay, maybe this time another account want to send some different values, some different amount, the smart contract balance has to be updated, right? So for that to happen, what we are going to actually do is we'll call the state variable and we'll increment will update it with value, but that is basically msg dot value. Okay, so if you remember, this is the amount which will be part of a metadata in the blockchain. So whenever somebody send the transaction, the received balance variable will be updated by that. Okay, so every time somebody sends some amount, it will be updated. Okay, so that's how exactly it would be. And our next function basically going to double the amount. So we have an existing amount, somebody sends some money, and our next function basically double it. Okay, so it's a beautiful game going on. Okay, let's deploy it and see. Let's compile it first and see if there's any error. Lovely, there's no error, it looks green. Let's go to our compiler, let's go to our deploy and run transactions. So we'll have to first deploy the transaction. Now what are the number of buttons you can expect? So first, we earlier had balance, I changed it to receive balance just to make sure it makes sense. Receive balance, send money contract, and again 3, right? Wonderful, 3. So now let's first do one thing. Let's first send some money, and now let's select another account, maybe 4B. Okay, 4B, you see this, right? So now send some money from here. Amount should be maybe 15 ether. Okay, and 15 ether I wanted to send it to, so I click on send money. Perfect. Now I have sent 15 ether. You see this 15 way. This indicates it's 15 ether. Way is basically the, I told you, right? It's the very lowest denomination of it, right? Just now what we need to do is we need to take a look at the received balance. What should be the received balance? What do you think? The received balance has to be taken from the message value. You see this val? This is nothing but our message value variable. This is the message value information. Okay, so every time a new value comes in, this value will be added to our received balance. So received balance supposed to be 15, isn't it? You see this? And now once we double it, okay, and once we double it, it should be get doubled by the amount that we enter. Okay, so let's say the current amount, but it would be irrespective of the amount we are talking about. Okay, so if let's say we give another amount, maybe 15, maybe 19. Okay, so in that case my maybe let's say 19 is not really that good, so my double the amount. So in that case the amount would be double, and I should be able to see that. And you see that the amount 20, right? So that means that is the amount I received, and the balance, the new balance should be double in that case, right? Because I entered 20, it became 40 at that moment, right? So that's how exactly it works. Now if I send some more money, let's say I send some more money to Ethereum, maybe I use another account, maybe this one, and I send some more, let's say 10, and I send the money to it, you could see the received balance would be 10, right? And again, it depends. I can probably multiply the existing amount itself, or I can do it by my own way. Let's say I don't want the user to input the value, but because it doesn't make sense, right? I want the exact amount to get doubled here, so I can just remove it, and I can simply, I can just double it here itself. All right, so my amount has been currently 10, and because I don't want to take any value from the user, so I have to compile the code from the beginning. So I should cancel it, compile it again. It's good. Now I should deploy it. I get all 3 values, and you see that there's no field because there's no parameter, right? Now I send some money. Let's say I send 10 and I should receive 10 on my smart contract. So my value of my smart contract balance should be 10, and my received balance should be 10 as well, because there's no earlier. By default it's 0, so right, so it would be added and become 10 in that case. When I double it, it should become 20 automatically, right? And when I check the receipt balance, it should become 20, right? You see this? I got some money on the smart contract. I applied the double money function, and when I check my balance on the receipt balance, it's become double. You get the idea, right? I hope you got the every piece of this smart contract, how I made use of state variable, global variable, payable function to receive the money, to send the money to smart contract itself. If you have any question, you can ask me in the comment. In this video, we are going to learn about different value types in Solidity. All right, so let's begin. We have covered a couple of them earlier, especially the integer. In this video, we'll be talking about some more valuable value types. Okay, so value types are the part of data types. Okay, so data types is the main hierarchy. There are two types of value types. There are two types of data types, in fact. First is, of course, the value types, and the second is the reference type. Value type is the variable that stores the value in it, okay? That stores the value directly with its on its memory location. But reference types are the type of data type that points to a specific memory location, like array. You will get to know about mapping as well, struct, and all those stuff, right? In this video, we are just going to talk about the value types. Okay, so we'll discuss about boolean, we'll discuss about integer, unsigned integer, address, and there's one more which is a bytes 34, which is not really that important, so we'll probably cover in another video or something. Okay, so let's begin. Let's understand the boolean first. So as you know, if you are coming from the programming background already, or mathematics as well, you know what boolean belongs to. But just to show you in the program, so this is how it would really works. So we can create our code, Pragma Solidity, and then we specify what version we need to go for. So we can specify 8.1. So the compiler will be used accordingly. Make sure you always keep the license mentioned, maybe MIT license that usually I prefer. Otherwise you get a warning alerts or something. Let's understand let's create a contract first. Contract, maybe sample contract. Okay, and then under this, let's create a boolean. Okay, now boolean is basically declared by using bool, and that's where we can keep it as public. We make sure it is public so that our remix can also identify it, and it become a part of state variable. Okay, now if you're following the playlist, you would understand what state variable would be, because the value of state variable will be stored in the blockchain, and blockchain can access it any moment of a time. But the value of the local variable is actually vanished once the function is complete. Okay, so now let's give it a name. Let's say I want to create a boolean or any kind of function that should start or that should just restart the service. So I can create a boolean maybe to service start. Okay, so I say okay, service start is my boolean, and I can keep it as, by default it should be off, so I can keep it as false. Okay, so a boolean could be either false, true, or false, right? There's no other option. And then I can of course create a function. Okay, and the function would be to restart the service. Okay, so I can restart service. This is the camel case style of using the function or variable as well, so you can probably get the idea. it's better if you make use of camel case every time. Contract, the first letter has to be, should start with the S. So yeah, that's something which you can follow as a part of standards, nothing really special. Okay, now I can keep it as public, so that again this function can be identified from blockchain. Now under this function I can do the activities, like just like any other function in the programming language. We can do the certain activities, certain set of activities in the function. Similar to that, we can do it over here as well. So we can set the value of the boolean here, so that we want the service to be restarted, right? So we can make use of same variable over here, and then we can say okay, true. It's that simple, right? Let's see if this works, right? So we can go to the compiler and we can commit, we can compile, sorry, we can compile, and looks like it worked. You can see the checks, and then you can actually deploy the smart contract. And once you deploy this, you get the event, right? You get the logs of it, right, over here. And from here you can get the clear understanding who deployed it. You can see the account from what I used to deploy was 583. That's the one I used, and for the smart contract, right? And you can also see the deploy contract. I'm supposed to have only two pointers here. One is for boolean, another one for service, restart the service. So at this moment the restart service is by default. Once you restart the service would be by default restarted. But if you look at the service start status, because I just clicked on the restart service, so the initial value was set to be false, but the current value is supposed to be true, and that's what you can see here, right? So that's what it is. That's how it basically works, right? So I think you get the idea about how the boolean works. Now let's go and discuss. Now let's work on another variable. Maybe let's work on the unsigned integer. So see, unsigned integer is very different. If I talk about signed integers, are the one where we also consider the negative value as well, but for the unsigned integer we only consider the positive value. So by default when we type un, that means it belongs to un 256. So that means that much of a value I can possibly make store basically. So 2 raised to power 256, sorry, 2 raised to power 256 minus 1, probably, yeah, of course. That much of a value I can store, and that's probably enough to store any kind of information or number or hash or any sort of stuff, right? So if you want to store a hash value, if you want to store any kind of information related to number or anything, that's pretty much enough for it. You can even be specific to store or to play with your memory space or something. You can even make it to unsigned integer for 8 as well, right? So that's where it will only be using 2 raised to power 8 minus 1 of a value, right? And you also have signed option as signed integer options as well. Again, similar to that, I mean, the range basically differed. That's where we can go from 2 raised to 256 minus 2 raised to 255 basically, because that's where values basically start. And yeah, in fact, remember that the values always be 2 raised to 255. I have by mistakenly told you about 256, so you can make a note of it, right? So 2 raised to 255 and till 2 raised to 255 minus 1. So that's the overall range and signed integer can range from, right? So I hope you get the idea. You can of course create a signed integer to take a balance. Maybe let's say you want to create a signed integer maybe for 8-bit, and that's where you can make it as public, and you can say balance received, and you can specify a number, maybe 2 or any sort of a number, right? Maybe 2000 or something, right? So that would store that much of a value. So if you go and compile it again, basically that's something where we have to literal large fit. So that's something which is the large value than this. So I forgot to do that. So I can make use of a different value altogether. So you're getting the idea, right? That's the decimal value, and that should be converted to the integer, and that would be a larger size. So you can even go for 64 and all those stuff and try and test it yourself. Again, you can go and deploy the contract and see yourself that what went wrong and what's the current status. At this moment of a time, this is my service start boolean, and again we can see the status of it, right? It's supposed to be false, you can see that, and once you restart the service, it should turn to true, right? So if I again go to and look at the service start status, it should be true now. And of course I can look at the balance received. You can always see if it's unsigned 256, the balance is 2000, right? So that's what the these two value types really looks like. There's one more very interesting, very important value type available as well, which will be making use of it very often. So that's address. So whenever we want to we want to store the value of any account, we make use of address. That's very specific to the Solidity, right? In order to call it, we just have to specify address, and we can make it public so that the value can be stored in the blockchain. You know it, right? And then we can of course make it as owner, right? Maybe owner or wallet address or wallet address or something. And probably you can define a value over here itself by giving any random account number, or you can keep it as a variable and probably can set it later as well. So that would work absolutely fine. Even if you compile it right away, I mean, that's absolutely going to work, and you can see how Solidity, once it's deployed, how it really looks like. You can again check the status of the service. You can restart the service, again come back, you should see true, the balance received 2000, and wallet address, right? So by default for any number, the default value is 0, and that's what you see here. That's the address which is being initialized. All right, I think you got the idea about these value types. If you have any questions, you can ask me in the comment. I would love to answer them. All right, welcome back everyone. In this video, we are going to learn about constructor function. Well, constructor function are used to initialize the state variable, okay? And the constructor function is executed only once. Remember this. After executing the construction, once the contract has been deployed, there is no further execution, or nobody can go back and call it up. All right, so it execute only once. Now, what do you mean by initializing the state variable? There are some situations when you can't really replace. It's become impossible to replace state variable with any constant value. In that case, it becomes very useful. All right, so without taking much time, let's get started with the actual lab, and let me show you how that exactly works. I'll take an example of a sample contract, and let me give a name, maybe sample contract, and what we'll do is we'll create an address. So we'll keep it public so that we can work with our remix, and it can be recognized by our remix tool as well. Then let's give a name. I'll define wallet owner. Okay, and what I want is the one who deployed the smart contract in the beginning should become the owner. How can I do that? One thing would be you can manually assign the address. Well, that is good enough, but when you are with the coding, you shouldn't be doing this, right? Your job should be automating this stuff. So what we are going to make use of is the global variable. If you are following me throughout, you get the idea of what I'm really talking about. So what exactly we are going to do is we'll create a constructor function, and remember constructor function Usually with the earlier version, the constructor function name should be same as the contract name, but now things got changed, so you can have constructor function constructor written as it is, and then you can have a bracket, parentheses, and you can specify what should be your wallet address. So your wallet owner, would be the message.sender. That's the global variable, right? If you have been following me from the beginning of this playlist, you get the idea what exactly message sender is all about. I'll show you even if you didn't catch it. The contract is ready. Let's compile it. The moment you do the contract, you can save the contract, you can compile the contract over here, and you can see the compilation is good. There's no error. Let's go to the cancel this. We can close this. What we have as the earlier deployed contract. Let's deploy a fresh contract now, and let me deploy it. The moment you deploy, what's going to happen is your wallet address is this. Starts with 583, right? And it should become the wallet owner. You should automatically become the wallet owner in that case. So if you see, the wallet owner will be 583, the one who actually deployed the smart contract. You see this? That's the beauty. And how exactly it worked is, if you look at the logs, it was generated. I mean, the from message gives you the idea about the message sender, the one who actually sent the message. And in the blockchain network, it actually goes into the blockchain. So blockchain maintain the data of it, right? So 583 becomes the wallet owner in that situation because he was the message sender, right? So this was about address, and this is very much being used for ownable function to make sure only owner can do the some privilege commands or privilege activity. You can we make use of constructor function so that we can initialize it, and then we make use of require commands or require a function to make sure it is ownable, right? So what you can think about it, what could I do in order to initialize a value maybe? So in order to initialize a value, you can again have, let's say, any number. Let's say it's a balance or maybe current balance. Current balance. And what you can do is you can just maybe, I have a habit of making use of underscore and the parameter, so you can probably try that. So that would be good enough. And then you can have, it depends. I mean, now you can initialize this value as well. So depends on this, you can, you want the user to enter the initial amount, so that this initial amount would be the seed amount, like seed funding, right, for the startups, right? So this is exactly would be funded to our smart contract in that situation. So I want this to be added as part of the initial amount to my current balance, right? So once it is done, then I can actually, go back and save this up, and then I can compile this again, and there is no error. That's wonderful. I can come back here. Now when you see something here, there's something really interesting. Now at this moment of time, while deploying this smart contract, you also get a parameter. You see this? You also get an option to specify some numbers, and then you can deploy it. Earlier it wasn't the case. You would have directly deployed the smart contract, but now you get an option. So let's say we give some number. Okay, we give any random number, that to be our initial amount, and the moment we deploy it, our wallet owner will be automatically created. We earlier tried with a different account number. Let's try with maybe third one. Okay, so my wallet owner should be 4B in that case, and my current balance should be this much of amount, right? Let's deploy. Something happened. Wonderful. My current balance and wallet owner both are public. That's why my remix can see that, right? So wallet owners is perfect. 4B, that's perfectly fine. It's pretty good. Now the current balance has to be perfect. You got the idea? All right, so if you have any question about how about the constructor function, you can ask me in the comment. I would love to answer that. Thank you so much.